Hello my dear students, how are you? I hope you are well and safe, and I welcome all of you on this educational platform one more time. Students, in the last classes we have discussed about the various content of this chapter, structure of atom, and we covered the entire unit in different lectures. Now in today's class we shall see that what type of question have been asked from this unit in the previous year's examinations of NEET and IIT. So in this class today I will discuss few numericals and questions with you of previous year's question. Alright, so let's come and start today's session, which is about the discussion of numerical from the previous year question papers. In this class we shall discuss few numericals with you which came in the competitive examination like IIT JEE entrance examination and All India pre-medical test examination, which is nowadays called as NEET. So here are few questions. The first question which is in front of you is the frequency of radiation emitted when the electron fall from n is equals to 4 to n is equals to 1, means electron is transiting from fourth to first shell in the hydrogen atom, and you have to find out what is the frequency of the radiation which is involved in this transition. Now we will begin this question with the help of ionization energy. Students, in this numerical, ionization energy is given for hydrogen, and we already know that ionization energy is equals to minus of E1. So with the help of ionization energy, suppose if you have the value of IP, ionization potential, you will have the value of first shell energy. So E1 will be minus 2.18 into 10 to the power minus 18. This is the energy of first shell. We already know that energy of nth shell is proportional to Z square by N square. So now in order to get the value of energy of fourth shell, what exactly we will do? We will divide it by 4 square, which is 16. So it will be minus 2.18 into 10 to the power minus 18 divided by 16, and the units will be joule per atom. Joule per atom similarly. So now what you have in this question, we have the energy of first shell, we also have the energy of fourth shell. Now what we will do? Now we will calculate the change in energy delta E, which will be equal to E4 minus E1, and because transition take place between these two shell, so whatever the energy change between these two will be equal to h nu, that is Planck's constant and frequency. So what value we will have here after putting the value minus 2.18 into 10 to the power minus 18 divided by 16 minus energy of first shell, which is again minus 2.18 into 10 to the power minus 18, which shall be equal to the h nu. We already know the value of Planck constant h, which is also given in this question, 6.6 into 10 to the power minus 34. So finally this value will become 15 by 16 into 2.18 into 10 to the power minus 18 is equals to h nu, which is 6.6 into 10 to the power minus 34 into nu, frequency. This is what we need, frequency. After solving this equation, students, frequency will come approximately 3.08 into 10 to the power plus 15 hertz or cycle per second. So right answer of this question will be option number 2, and this question was there in All India Pre-Medical Test 2004. Alright students, so this was the question about energy of electron. Now the second question. See, this question says if the measurement of the electron position is associated with an uncertainty in momentum, and yes, of course it is. We studied that under the heading Heisenberg's uncertainty principle, which taught us that we cannot calculate position and momentum of electron with the accuracy simultaneously. Alright, so the uncertainty in momentum and uncertainty in position are concerned with each other. Now, uncertainty in position, the measurement of the uncertainty in the position of electron is equal to 10 to the power minus 18. Now we have to find out what is the value of the uncertainty in the velocity of electron. So here you have to find out what is the value of uncertainty in the speed of electron. Alright, so what formula we will apply here? Students, we will apply the formula of Heisenberg uncertainty principle. Delta x dot delta p is equal to h upon 4 pi for the sake of numerical. Right. Now delta p, we can call delta p is m delta v, mass into uncertainty in velocity. So delta x dot m delta v is equals to h upon 4 pi. Now, as given in this question, we have to find out the uncertainty in speed. So students, that is delta v. What we need is delta v. So that will be equal to h upon 4 pi m into delta x. Now next what we will do in the next step, students, we will put the values. Delta v is equals to, what is the value of h? 6.6 into 10 to the power minus 34, which is further divided by 4. The value of pi is 22 by 7, which is then further multiplied by the mass of electron, which is 9.1 into 10 to the power minus 31 in kilograms, and the value of delta x, which is already given. After putting this value and after solution of this equation, you will get the value delta v is equals to approximately 1 into 10 to the power 9 centimeter per second. So your answer will be option number 2. Now here comes the third question. This question was there in All India Pre-Medical Test 2009. It states maximum number of electron in a subshell of an atom is determined by which of the following? Suppose you have any subshell. Please understand this question. What he is asking, suppose you have any subshell for which the value of azimuthal quantum number L is something. Now whatever it is, definitely it will have some certain value. So for any subshell, the value of azimuthal quantum number is L. How many orbitals we have? How to calculate the value of orbital? In order to calculate the value of orbital, we will assess the value of azimuthal quantum number. For the value of azimuthal quantum number L, if the value of azimuthal quantum number is L, then number of orbitals will be 2L plus 1. So students, this is equal to the number of orbitals. But this is not the answer of our question. In this question, what is being asked is the number of electron. Now we know that each orbital possesses how many electron? 2 electrons. Each orbital can accommodate 2 electrons. So total number of electron, students, total number of electron will be equal to twice into number of orbital. So whatever the number of orbitals we have, number of electrons will be twice of that. So 2 into 2L plus 1, and the solution will be 4L plus 2. This will be equal to the students what? Number of electron. So the right answer will be option number 2, 4L plus 2. And this was the question in All India Pre-Medical Test 2009. Now one more question from Pre-Medical Test 2009. It states, it is very interesting question, and it is very common question. Examiner usually asks such question in the medical entrance examination. This is about the set of quantum numbers. Students, if you remember, we also discussed this kind of question when we were studying the concepts of the chapter. It simply says, which of the following is not permissible? Please pay attention. He's not asking permissible. He's asking not permissible, which means out of these four options, which set of quantum number is not permittable? Which of the following set is the quantum number is not permittable? So in this, when n is equals to 3, the first set, now we will discuss the first set. If the value of principal quantum number is 3, azimuthal quantum number will be lesser than 3. We know that value of azimuthal quantum number varies from 0 to n minus 1. So if principal is 3, azimuthal will be 0, 1 or 2, which is 2. So this is correct. If azimuthal is 2, magnetic could be from minus 2 to plus 2, which is in the range. So this is also correct. And the value of spin quantum number is independent, which is plus half or minus half. So overall this set is correct. There is no problem with this set, and this set is permissible. Now another set. If the value of principal quantum number is 4, azimuthal could be 0, 1, 2, 3. Here it is 0, so it is allowed. If azimuthal value is 0, then magnetic will also be 0. So this is also allowed. And S is plus minus half again, which is correct. So this set is overall correct. Now what about third set? In the third set, you see principal quantum number is 5. When principal quantum number is 5, possible values for the azimuthal quantum number could be 0 to 4. Here it is 3, so it is allowed. If L is 3, M could be minus 3 to plus 3, which is in the range. And S is plus half, which is also allowed. So this set is completely correct. Now what about the fourth one? If the value of principal quantum number is 3, value of azimuthal quantum number could be 0, 1, 2. Now this is correct. But if the value of azimuthal quantum number is 2, how can you say that magnetic quantum number is minus 3? Because magnetic quantum number is always from minus L to plus L. So this is not in range, and this set of quantum number is not permissible. So right answer of this question will be option number 4. Now this set is not permissible. Here we go with the another question. This question belongs to de Broglie's concept with the dual nature of light. Now in this question, which belongs to Heisenberg's uncertainty theory, mass of ball is given. This question says that mass of ball is 0.66 kilogram. So we have a ball with a mass 0.66 kilogram, and it is moving. It is not stationary. It is moving with the speed of 100 meters per second. Now, as per the de Broglie, whenever there is a moving mass, there will be association of some de Broglie waves with the particle, and the wavelength of this de Broglie wavelength is given by lambda is equals to h upon mv. So now what do we have here? We have mass of ball. Yes, we do have. Do we have the speed of ball? Yes, we do have. And we have to find out the wavelength. So wavelength will be equal to 6.6 into 10 to the power minus 34 divided by mass, which is 0.66, into speed, which is 100. Now if you will solve this equation and you will solve these values, the final answer will come 1 into 10 to the power minus 35 meter. So the final answer will be 1 into 10 to the power minus 35 meter, which is option number 2. So for this question, answer will be option number 2. So these were few questions we discussed from previous year pre-medical examination. Now we will discuss few questions from IIT examination. See, in this question, this was the question in joint entrance examination IIT JEE 2002. This question asks, it says, in the Rutherford experiment, we know about the Rutherford alpha scattering experiment. So it says, in the Rutherford's experiment, which established the nuclear model of atom, used beam of. So what beam, what kind of beam was used in the Rutherford's experiment? everyone knows that the beam which was used in the Rutherford experiment was alpha particle, but there is not a single option which says alpha particle. Option number 1 says beta particle which falls on the metal foil and get absorbed. Definitely it was not beta particle. Second option says gamma particles or the gamma rays which falls over the metal foil and they eject electron. No, it was not the gamma rays. We also know that in the Rutherford experiment we use the beam of alpha particle. Now if I ask you a question, what is alpha particle? What is alpha particle? Students, alpha particle is double positive charge. It is double positive charge helium nuclei. So if you take the helium nucleus with the double positive charge, this is alpha particle. What is the composition of helium? Helium is 2He4, which means it has 2 protons, definitely 2 electrons and 2 neutrons. Now what will happen if you will remove 2 electrons of helium? This will become helium plus 2. Students, this helium plus 2 is called as alpha particle. So alpha particle is nothing else but helium plus 2, or you can say helium nucleus. So helium atom is the wrong option, while helium nuclei which falls on the metal foil and got scattered is the right answer. So D is the right answer of this question. Now another question. See, this question was there in the IIT JEE entrance examination 2004. The radius of which of the following orbit is exactly same as that of the first Bohr orbit of hydrogen atom? What does it mean? Means examiner is asking that out of these four options, which one will have radius of exactly equal of the same radius of hydrogen? Means whatever the radius of hydrogen, first shell of hydrogen will be equal to the radius of which of the following? We already know that radius is proportional to n square by z. For hydrogen, if you calculate it for hydrogen, let me tell you, for hydrogen value of z is 1, and if you are calculating the first orbit, n is also 1. So here radius is proportional to 1 square by 1, that means proportional to 1. Now the same value will be for which option? If you choose the option A, for the option A, radius will be proportional to n square upon z. For helium, z is 2, and for second shell, n is 2. So it will be 2 square upon 2, that means proportional to 2. So this is not our option. Option number B, it says second shell of lithium plus 2. So here radius will be proportional to 2 square divided by 3, which is 4 by 3. Proportional to 4 by 3, again it is wrong. In the option C, radius will be proportional to third shell of lithium plus 2. So it is 3 square divided by the atomic number of lithium, which is 3. So it will be proportional to 3, which is again wrong option. Now in the option D, radius is proportional to n square upon z. The value of n is 2, so it is 2 square, and for beryllium atomic number is 4. So it is 4 by 4, which is proportional to 1, as same as that of hydrogen. So our right answer will be option number 4, D, second shell of beryllium plus 3, which means second shell of beryllium plus 3 will have exactly same radius as that of first shell of hydrogen. Now in this question, this is a numerical question which you have to solve, and this was asked in the IIT 2005 entrance examination. This says calculate velocity of electron in the first Bohr orbit of hydrogen. So first I shall calculate the velocity of electron. Students, velocity of electron, see what is the formula for the velocity of electron? It is 2.188 approximately into 10 to the power 6 multiplied by Z/n meter per second. Now in this formula you have to put the values. Since here we are calculating radius for the first Bohr orbit of hydrogen, for hydrogen value of Z is 1, and if we are talking about the first Bohr orbit, n is also 1. So after putting these value, this value will become, this is V1 of hydrogen, means velocity of electron in the first shell of hydrogen will become 2.188 into 10 to the power 6 meter per second. So this is the answer of first question. Now what second question says? It says find out de Broglie wavelength. It is asking de Broglie wavelength of the electron in the first Bohr orbit. For the solution of question number 2, we know that de Broglie wavelength lambda can be calculated by using formula h/mv. Since mass of electron in the first Bohr orbit we already have, so the wavelength will be 6.6 into 10 to the power minus 34, which is Planck constant, divided by the mass of electron, which is 9.1 into 10 to the power minus 31 kilogram, multiplied by speed of electron, which we have already calculated, 2.188 into 10 to the power 6. Now we have put it all the values in this equation. After solution, the final value of wavelength will come approximately 3.31 into 10 to the power minus 10 meter, which we can also write 3.31 angstrom approximately. So this will be the answer of question number B. Now in the question number C part of this question, examiner asked find out the orbital angular momentum. Orbital angular momentum. Students, how to find out the orbital angular momentum? Orbital angular momentum. Do you remember I told you about this in the class? Orbital angular momentum is calculated by using the formula under root L into L plus 1 h upon 2 pi. In this equation, what is the value of L? Is the azimuthal quantum number. Now the question is being asked for 2p orbital. For 2p orbital, value of L will be 1. So orbital angular momentum will be under root 1 into 1 plus 1 h upon 2 pi. So final answer will be under root 2 h upon 2 pi. This will be the answer of this part 3rd. This is the answer of part 2. And here is the answer of part 1. Alright. Now the next question. This question says the maximum number of electron that can have principal quantum number n is equals to 3 and the spin quantum number minus half. See, if the principal quantum number is 3, how many shells are possible? For principal quantum number 3, shells are also 3. How many subshells are there? Subshell will also equal to 3. Which one? Let me tell you, 3s, 3p, and of course 3d. Now in these 3 subshell, how many orbitals are there? See, we have s, 3s specifically, 3p, and 3d. And what about the number of orbitals? What do we have here? 1 orbital here, 3 orbital here, and 5 orbital here. And we also know that in each orbital we have 2 electron. So out of these 2 electron, only 1 electron can have value of s plus half, and 1 will have the value of s minus half. So the value of s minus half will be equal to the number of orbitals. So how many orbitals are there? 1 plus 3 plus 5. So the final answer will be 9. So here 9 orbitals, here 9 orbitals can have, same value of a spin quantum number plus minus half and also plus half. If you calculate, it will be plus, for plus half also the answer will be same. Alright, now the last question. This question is about the photoelectric effect, and this was there in Joint Entrance Examination 2011. This question says work function, which is psi. Work function of some metal is listed below. Phi is the value of work function which is given below. And how many metals will show photoelectric effect when light of 300 nanometer wavelength falls over the metal surface? Now we know, for showing, I told you, for showing photoelectric effect, energy of photon, students, energy of photon should be greater or equal to the work function phi. Now what is the energy of photon? E is equals to hc upon lambda. If you will put the value of h, 6.6 into 10 to the power minus 34, value of c, speed of light, 3 into 10 to the power 8, and of course value of wavelength, which is 300 into 10 to the power minus 9 meter. After solution of this, whatever the answer came in joule, you will multiply it by the electronic constant and convert it into electron volt, and the final answer of energy will be approximately 4.1 electron volt. So all the metals which have value of work function phi lesser than 4.1 electron volt will show photoelectric effect. So how many metals we have here which have the value of phi lesser than 4.1? Lithium is there, potassium is there, yes, sodium is there, yes, and magnesium is there. But photoelectric effect will not be there for copper, silver, iron, platinum or tungsten, because they have value of work function greater than the energy of photon. So only 4 metals, here 4 metals will show photoelectric effect. So students, these were few questions we discussed from the previous year's examination from this chapter. Now I will discuss the another chapter with you. I hope you like this chapter and like these questions. We wish you good luck. Please keep coming and keep studying and stay safe.